118.1. $14.5. $120.7. $107.6. There's 2 more points for this water quench. Let me get one thing from the corner. Look at that. This is at the corner. 123.5. Over. $123.1. So if we want to discuss that, the water quench one means this steel, it heated up in 725 degrees Celsius and then put it inside the water, fast quench, we get that. So what we do, we bring the carbon content inside this to the surface and make it more harder. But this one, because of fast cooling, is very breakable. Even if we can apply more pressure, we can break it. Okay, so why this happened? Because we increased the hardness, but the toughness decreased in this one because of residual stresses we have. As you can see, this machine shows us the hardness. So based on the hardness for the same method, HRB, increased 30 unit approximately. For this one was around 90. And we get around 120 for this one. Means this increased that 30. So how we can get rid of the residual stress in that and improve the toughness? Because we don't want to have it break very fast. Because if you apply force on it, at some point load on it, it's going to break. We want something very strong. It is good in terms of hardness, but we need to improve the toughness. Now we are going to introduce air quench. Means we are going to heat up this for 400 degrees Celsius. I mean the water quench one. We are going to heat it up for 400 degrees Celsius inside the furnace. Then we leave it in a room temperature and let it to cool down, which we named that air quench. So that one, when you heat up again that, you are going to lose a part of the hardness. You sacrifice your hardness, but you are going to increase the toughness in this one. Means this one going to have a hardness less than this. This one was 130. It's going to sit between this and this. Around 110, 120 we guess to have for this one. But that's going to probably keep more loads. Let me make an example for you. If we have, let me make these samples. So this is our normal sample. So I need to set it up somewhere and explain. So normal sample. This is untreated, water quenched, and air quenched. So this one, if we apply load on it, just an example. I make an example here for you, but these values, they are relative value. If you apply a bucket here and you put load in a bucket, see when it's going to break. Let's say that's going to keep 16 kilogram for us. If you do the same thing, it's going to be 6 kilogram. Why? Because the toughness here is low. And if we heat it up that and let it to cool down in air, the value of this one going to be around 60 kilogram. 10 times bigger than this and 4 times bigger than this. So toughness improved here, but if we check the hardness for those, hardness for this one going to be 90, for this one going to be 130, for this one going to be 110. So this is a trade-off for us. Why? Because we sacrifice part of hardness to 110, but we increase the toughness. So now let's check the air quench one here for 10 different points and see what we're gonna get. One oh six. $95.4. $105.3. $105.5. $88.4. 106.5. $104.8. Over. $107.6. And the last point. $93.8. So if we check right now on board, those are the values for untreated steel. As I said, 90. And when water quench, it means heat up to 723 degrees Celsius and then cool down in water. We get that 30 unit bigger. So for this one, if I want to write down hardness increased, but toughness decreased because of residual stresses. So then I again, this sample, I heat it up to 400 degrees Celsius and air cooled. So as you can see, the value is less than this, but greater than this. 10 unit less than this, average minus 20 unit. Or 10, 15, let's say. But hardness sacrificed a little bit, toughness increased. So this is what we are looking for. We name that, come to margin side, and this one is, I'm going to write it down. So let me take it out from here. And this one, minus 15 unit. So I'm going to say this one is margin side, and this is tempered margin side. So the next lab, talking about the furnace and how we create margin side and tempered margin side, going to be our last lab, which you guys could use those results for those labs too, because there is a combination between lab 4 and lab 5. So thank you very much. There's going to be a lab handout, by the way, for this, and you are going to discuss those results. These results, I don't provide them in Excel sheet to you, so this is what you have in the video here. You should take those results work on them, make the Excel file, average, and just discuss them and elaborate the outputs based on what we have for HRB hardness test. Thank you very much.